In this lesson, we will solve equations with fractions by clearing the denominators. Now, if we were asked to solve an equation like this that has multiple fractions in it, I'm not saying that you can't solve it the traditional way where we isolate the variable, we would subtract 1/2 from both sides. So I'm saying you can do this. I'm going to show you a different method that will get rid of all the fractions from the beginning. Because if you do it this way, which again it's fine, but if you do it this way, now you're going to have to subtract fractions. So let's pretend we didn't have a calculator that can just do 5, 6 minus 1/2. Then you would have to remember your fraction rules. When you subtract fractions, you need to find a common denominator, so make the denominators the same. And then, after we do that and get 1/3, now to get this variable by itself, we have to multiply by the reciprocal. So now we have to remember multiplying fraction rules. And we know we can cross simplify, and we get 1/2 or 0.5 for p. So instead of doing it this way and keeping the fractions all throughout, we're going to learn how to get rid of the fractions from step 1. So here's the steps, and if we do it right, it will clear the denominator and get rid of the fractions. So step 1 is you're going to find a least common denominator for all the fractions in the equation. And then the second step is we are going to multiply and distribute that common denominator, that LCM that we found, to all the terms, and that's key. We need to make sure that we multiply it to everything in the equation. And if we do that step correctly, note this step will clear the fractions. So, as you saw, we did this problem, we left the fractions in the problem. Now we're going to go ahead and solve it again, but by getting rid of the fractions from the beginning. So the first step is we need to find a least common denominator, which you've learned how to do that from the class before this class. So the denominators are the bottom numbers here. And we need to think of a number that 3, 2, and 6 can all divide into. So there's many numbers. For example, 6, 12, 18, 24, etc. But we want to use the least one because it's nicer to multiply with a number that's the smallest. So I'm going to go ahead and use 6 because all these numbers, 3 can go into 6, 2 can go into 6, and 6 can go into 6. So that's why I'm picking this number here. So now that we have that common denominator of 6, we're going to distribute 6 to both sides of the equation. So what that means, essentially, is that we're going to multiply 2/3 by 6. We're going to multiply 1/2 by 6. And we're going to multiply 5/6 by 6. Every single term in the equation by 6. Now, we should be able to do that using mental math. I'm going to show you, without mental math, doing it the long way, what's happening to review your fraction rules. So the reason why we selected this number here is because when we take this 6 right here and multiply it to 2/3, let me show you what's happening here. When you multiply, we've learned from the class before that you could take these two numbers right here and simplify them and divide out the common factor. So 3 can go into 3, and 3 can go into 6. So this will become a 2, and this will become a 1. Do you see how there's nothing left in the denominator but 1? That's why we picked 6, because this 3 right here will go into 6. And then we're left with 4. So when we multiply this here, we would get 4p. Okay, so now if we do 6 times 1/2, again, you should be able to do this in your head. But for this first one, I'm going to write it out so you could see why we could do it in our head. So when we multiply 6 times 1/2, the 2 is going to disappear because 2 divided by 2 is 1. So this is going to change to a 1. And then 2 goes into 6 3 times. Then you multiply straight across. 3 times 1 is 3. And then these change to 1, so you just get 3. So we're going to have plus 3. Notice the fractions are clearing away from the equation. Okay, so now we have 5/6 right here times 6. Again, this can be done in your head because this 6 is going to change into a 1 because it goes into this 6. And then we're left with 5 times 1 is 5, and 1 times 1 is 1, so we just get 5. So we are left with an equation here to solve that has no fractions. Now this work here does not need to be shown, so let's go through it how you would do it using mental math. So if I was doing this problem with mental math, I would say to myself, 3 goes into this 6 right here twice. So it goes into this 6 twice. And then I would do 2 times 2 is 4. So I'm doing this in my head. And then here I would do 2 is going to go into this 6 right here 3 times. And then 1 times 3 is 3. And then 6 goes into this 6 right here once. So 5 times 1 is 5. And now I'm going to solve this equation, get the variable isolated. Divide by 4 since the variable term is isolated. And then p equals 4 cannot go into 2. You would get 0.5 if you were allowed to write it as a decimal, or as a fraction if you take 2/4 and simplify it. You would get 1/2. And that's the exact answer we got, keeping the fractions in the problem. So I promise you, if you try this method, you will find it a lot easier than working with the fractions throughout, especially if you didn't have a calculator. Alright, let's try this next one here. So the first step, if we don't want to deal with the fractions, we take a look at what's in the denominator of the fractions. And we need to think of a number that 7 can go into and 5 can go into. There's many different numbers, but I'm going to go with 35. So that's how I know to multiply everything. So essentially what we're doing is we're multiplying this side of the equation by 35 and this side. Whatever we do to one side of the equation, we have to do to the other side. Now, instead of writing it this way though, I'm going to go ahead and write 35 next to all the terms so I don't forget I have to distribute 35 to the whole entire equation. So I'm going to write it like that so I don't forget about this term right here. Alright, so now we should be able to do this in our head because 7 goes into 35 here 5 times. So 2 times 5 is 10x. Then we have 35 times 2 is 70. 5 goes into 35 7 times. So 4 times 7 is 28. And now there are no fractions in the equation. So I want to get my variable term isolated. So we'll add 70 to both sides. And then divide both sides, now that this variable term is isolated, divide both sides by 10. So since 10 can't divide into 98 evenly, we'd get a remainder. We're going to just simplify them. So 2 can go into both of them. So we would get 49 over 5 as our answer. Or if the direction said we're allowed to leave a decimal, we could divide it and we would get 9.8. Remember, the nice thing about equations is that we could always check our answers. So if I go back to the original problem and I take the x out and I put our answer we got here, a number next to an x means multiply. So if we multiply here, the 7 goes into 49 7 times. And then we would have 2 times 7 is 14. And then 1 times 5 is 5. And then we'd have 14 fifths minus 2. So if I do 14 fifths minus 2 without a calculator, I got to find my common denominator here. I'd have 14 fifths minus 10 fifths is 4 fifths. And it works. We get the same thing on both sides. Now, to be faster, you could just plug this into your calculator and make sure that both sides are the same. Alright, so if we want to get rid of the fractions, I need to think of a number that 2 can go into and 3 can go into. There are several numbers. I could pick 12. 2 goes into 12. 3 goes into 12. But there's a smaller number. I want to pick the least one. I don't have to, but it just makes it easier to multiply with a smaller number. So I'm going to go ahead and pick 6, since all the denominators can go into 6. So I'm going to multiply everything in the problem by 6. I'm going to multiply this by 6, this by 6, this by 6, and this by 6. So I should be able to do this in my head, because 2 goes into 6 3 times. And then I'd bring down the negative here. And 3 times 3 is 9. And then here I'd have 3 goes into 6, this 6 right here, twice. So 2 times 2 is 4. And then 6 times negative 5 is negative 30. Y. And then 3 goes into 6 twice. I'm going to bring down this minus here. And 7 times 2 is 14. And now I have no fractions to worry about in this problem. So I see that I have a variable on both sides of this equal sign here. I can't have that, so I need to get rid of one of them. So I'm going to go ahead and add 30y to both sides. So we'd have 21y. Now that I have only one variable, I can isolate it. And now that the variable is all by itself, the variable term, we divide. So here we have a negative divided by a positive, which is a negative. And then 21 can't divide into 18 evenly, so we're going to go ahead and ask ourselves what can divide into 18 and 21. So 3. So we'd have negative 6/7. We cannot write this as a decimal. If you put it into your calculator and you do negative 6 divided by 7, go ahead and do that with your calculator and see what it looks like. you will see that a bunch of numbers fill the screen. Some of the numbers are like this, etc. So in the directions, it doesn't say to round your answer for y, so we have to keep it as a fraction because it's an exact answer. We can't just put about negative 0.86 or something like that. The directions do not say to round, so we cannot do that. So we're going to leave it as a simplified fraction. This problem over here, we could write it as a decimal because the decimal terminated, it ended. But this problem doesn't, so we have only one choice to leave it as a fraction. So if we want to clear the denominators, we need to think of a number that 3 and 5 can go into. So we could pick 30, but instead of picking 30, I'm going to pick a smaller number, 15. Now, if you didn't realize it was 15, you could go with 30. So I'm going to multiply everything by 15. So 3 goes into 15 5 times. So in front of this variable, there's a 1. So I'm going to do 5 times 1. And then 5 goes into this 15 right here 3 times. So 1 times 3 is 3. And then 15 times 4 is 60. And now there are no fractions in the problem. I see that we have a variable on both sides, so I need to put them on the same side. So I'm going to go ahead and subtract 3x. And now that the variable term is all by itself, we divide by 2. And we get x equals negative 30. So if we want to check that answer, we would put a negative 30 back in for x. And over here we'd have negative 30 divided by 3, which is negative 10. Here we would have negative 30 divided by 5, which is negative 6. And we would get the same thing on both sides, so we would know our answer we got here was correct. Alright, last example here. So we only have one number in the denominator. So I'm going to use 7. So if I want to get rid of the fraction first, now this problem only has one fraction, I probably wouldn't clear the denominator, I would just leave it there. But if you see a fraction and you want to get rid of it right away, you got to multiply everything by the common denominator. So here we'd have 7 times 2 is 14. And then here 7 goes into 7 once. And 3 times 1 is 3. Bring down the m. And then 7 times negative 1 is negative 7. So now I can isolate the variable by subtracting 14 to both sides. And then negative 7 plus negative 14 is negative 21. Divide both sides by negative 3. And we would get m equals 7. So now this clearing the denominator, I probably, like I said, wouldn't do with this problem since there's only one fraction. As you could see, we would get 7 if we clear the denominator. Now the other way I could have done this is highlight the variable since there's only one of them, and I could subtract 2 from both sides. And then, to get this by itself, we divide. But we learned that instead of dividing, we multiply by the reciprocal. So we flip the 3/7 over and get 7/3. And if this is negative, this has to be negative so that a negative times a negative would make a positive m on this side. So these are going to cancel. And whatever we do to the left side, we have to do on the right side. Negative times a negative is a positive. And then this 3 goes into 3 once, 3 goes into 3 once, and we're left with 1 times 7. So we get the same answer by leaving the fraction there. So it's up to you which way you want to do it. Just make sure if you clear the denominator that you multiply all the terms in the equation by that common denominator.